This is section 2.6 of accelerated geometry, and it has to do with special angles on parallel lines. So I have all kinds of parallel lines drawn here on my intro slide. So the first thing we need to do is establish some definitions. We've already talked about this one, parallel lines. Lines in the same plane on the same flat surface that never intersect. A transversal is a line intersecting two or more other lines in the plane. Notice it says intersecting two or more other lines. It doesn't say intersecting two or more other parallel lines in the plane, even though that's what we're going to kind of concentrate on today. So here's a picture of line A and B, and there is a transversal line that is drawn that goes through those two lines. So in this picture over here, I have that EF and KL are transversals. Oh, KL is over here. So here are two lines, not parallel, notice, cut by this transversal, a line that goes through them. So EF is a transversal. Here it appears that GH and IJ are parallel to each other, and this line goes through them, so that's a transversal. So a transversal can go through two parallel lines, as in this case, or it can go through two non-parallel lines, as in that case. So we are going to talk now about these special angles on parallel lines. Notice that the angles we will investigate are all on the same transversal through parallel lines. So here are my parallel lines, and this is the transversal that goes through those two parallel lines. Notice that all the angles that we're going to talk about are all connected to that transversal. They're all on each side of the transversal. So angles 1, 2, 3, 4, 5, 6, and 7 and 8 are all on that same transversal. So I did a sketch pad drawing and set these up so that this is 150, this angle is 30. This is 150, this is 30. This is 150, this is 30, this is 150, and this is 30. And as we go through the other, I think, 5 slides, I'm going to kind of assume again that we have this same relationship of the 150-degree angle and the 30-degree angles. So first we're going to talk about corresponding angles. Corresponding angles are 1 and 5, 2 and 6, 3 and 8, 4 and 7. Okay. Corresponding. By corresponding, that means they're on the same side of the transversal and on the same sides of the parallel lines. So here's 1 and here's 5. They're both to the left of the transversal and they're both above their parallel line. Okay, I'll switch colors. So this is 2 and this is 6. They are also corresponding angles. 2 and 6 are on the right of the transversal above their parallel lines. And then I'll go to blue. 3 and 8, they say. 3 and 8. 3 and 8 are both on the left of the transversal, both below the parallel line. And then let's see if I can get a purple here. 4 and 7. 4 and 7 are both on the right-hand side of the transversal, and they're both below their parallel lines. Now, what did I say? This was going to be 150, and this was going to be 150. And if I go back and get this one would be 30, and this blue one here would be 30. And if I go back and try to get the red again, this would be 150, and this red one would be in the 150, and then I need the green. So the green, this would be 30, and this green would be 150. Whoops, not 150, 30, sorry. Okay, so now look at this. The red ones are corresponding angles, they're both 150. The green ones are corresponding angles, they're both 30. The blue ones are both corresponding angles, they are both 30. And the purple ones are corresponding angles, and they are 150. So therefore, if two parallel lines are cut by a transversal, then corresponding angles are equal. If two lines are cut by a transversal so that corresponding angles are equal, then the lines are parallel. So that's the converse of this. So this statement says if I start with parallel lines, then corresponding angles are equal. And this one says if I start with any two lines and I don't know anything about them except that their corresponding angles are equal, then I will know that the lines are parallel. So a statement and its converse, both true. This is conjecture 3A, and this is conjecture 4A that you'll be putting on your conjecture list. Okay, alternate interior angles. Okay, I'll show you what alternate interior angles are. 3 and 6, 4 and 5. Here's 3, here's 6. 3 is a 30-degree angle, 6 is a 30-degree angle. And then, different color, 4 and 5. This is 150 degrees, and this is 150 degrees. Okay, alternate interior. Interior angles are inside the parallel lines. So that would make those be 4 angles that are interior, inside the parallel lines. Alternate means that one is on one side of the transversal and one is on the other. So here's one on one side of the transversal, and this guy's on the other. Okay, let's do a different color here. This guy's on one side of the transversal, that guy's on the other. So alternate interior angles. Now look at them. 3 and 6 are alternate interior angles, both inside the parallel lines, one on one side of the transversal, one on the other, and they are both 30, so they are equal. Look at the other ones, 150 and 150. They are also equal. So if two parallel lines are cut by a transversal, then alternate interior angles are equal. And if two lines are cut by a transversal so that alternate interior angles are equal, then the lines are parallel. So again, this is the statement. It says I'm starting with two parallel lines, and if I have the two parallel lines, alternate interior angles are equal. This is the converse. The converse says I'm starting with any two lines. I don't know anything about them except that their alternate interior angles are equal. If I know that, then I do know that those lines are parallel. Alternate exterior angles. Okay, alternate exterior. Okay, if I go over here, I'm going to choose the yellow. These are exterior angles outside of the parallel lines. Alternate means one's on one side and one is on the other. So this guy and this guy are exterior angles, one on one side of the transversal and one on the other. This is 150 from our diagram in the beginning, and this is 150. So they seem to be equal. If I change color, this is an exterior angle and this is an exterior angle, and they are on opposite sides, different sides, alternating sides of the transversal. So they are alternate exterior angles. And from our original diagram, this is 30 and this is 30. So angles 1 and 7, 2 and 8 are alternate exterior angles. They seem to be equal. And if two lines are cut by a transversal so that I have alternate exterior angles that are equal, then the lines will be parallel. So again, this is a statement that says I'm starting with two parallel lines. They're cut by transversal, so then I know that the alternate exterior angles are equal. This one says I'm starting with any two lines. I don't know anything about them except that they create alternate exterior angles that are equal. If they do that, then I know that the lines are parallel. So again, there are two different conjectures here. One is called conjecture 3C, and the other one is going to be written at conjecture 4C. Same side interior angles. Okay, same side. Interior. So interior and on the same side of the transversal. So that's 4 and 6. Oops, I don't know why I did that. I kind of messed that up here. Okay, and let's go to a different color. This guy here and this guy here, 3 and 5, are on the same side of the transversal, interior, inside the parallel lines. Now, what do I know about those measurements? I know that, let's change to a different color here. This one is a 30, and this one is a 150. They add up to be 180. Look at this one. This is 150, and this is 30. They add up to be 180. So that means that they are supplementary. They add up to be 180 degrees. So if two parallel lines are cut by a transversal, then same side interior angles are supplementary. And then we do the converse. If two lines are cut by a transversal, so that same side interior angles are supplementary, then the lines are going to be parallel. And there is one more conjecture. Actually, we're doing two each time, so there's two more conjectures, the final two, and these are called same side exterior. So you can just about tell what these are going to be. So they're exterior angles. So here are exterior angles, but on the same side of the transversal. So this guy and this guy are same side exterior angles, and this are same side exterior angles. This is a 30, this is a 150, so again, look how they add up to be 180. And then these guys, this is a 30, this is a 150, they add up to be 180. So, if two parallel lines are cut by a transversal, then same side exterior angles are supplementary, and then the converse. If two lines are cut by a transversal, so that same side exterior angles are supplementary, then the lines will be parallel. So this one starts out saying, I have two parallel lines. If I have parallel lines cut by a transversal, then I know the same side exterior angles are supplementary. This one says, I don't know that they're parallel. I just know I have two lines drawn with a transversal going through them, and same side exterior angles are supplementary. Then I will know that the two lines are parallel. So altogether, we have added now 10 conjectures to our list today. That's kind of a record so far. Your homework is listed on the calendar for this section.